Hello students, I'm Professor KAKADE. We are learning Structural Design 1, the second chapter, Design of Connection. This is a fourth lecture of a Design of Connection. In the last lecture, we have studied the joints of the bolted connections. So there are two kind of joints, that is lap joint and butt joint. In this type there are division of different types like single cover butt joint, double cover butt joint, or a single bolted lap joint, double bolted lap joint. Their advantages, disadvantages, and all the terminology we have studied in the previous lecture. So in the next in this lecture we are going to learn about the terminology and failure of bolted joint. So these 2 points going to cover in this video, so stay tuned. The terminology content, there are 4 distance. While we are designing the connection, there are some notations or some values we are required for the designing. In such situation, we have to know about this terminology, that value, what is the definition of it, what is the maximum and minimum limit of it. So here it is. You can see on the right side of the screen, you can see the figure of this whole terminology. The first is the pitch distance, gauge distance, end distance, and edge distance. So here the notation for the pitch distance is P, for the gauge distance G, for end distance it is E, and for edge distance it is E dash. So what is mean by pitch distance? Here it is the distance from center to center of a bolt in the direction of applied force. So I forgot to refer here, there is a P, arrows on the left or right side of the figure or that plate is P, which is showing the force notation, like the force acting in tensile direction of a value P. So this direction, this arrow showing the direction of the load, and the distance between two bolts, center to center distance between two bolts in the direction of a load or force is known as an pitch distance. So it is the distance between two bolts. Okay, and next is the gauge distance, the distance between two consecutive bolts perpendicular to the direction of force is known as an gauge distance. So sufficient pitch and gauge distance should be provided when to avoid the different failure of the connection. So that's why this terminology came into the design chapter, to show the different notation and importance of it. End distance, it is the distance from end of the members up to a center of first bolt in the direction of applied force. So here you can see in the direction of applied force, where here you can see that the end distance in the direction of force, and edge distance, it is the perpendicular distance of a in the direction of force from center of bolt to nearest edge. It is the distance from perpendicular distance. So end distance is the parallel distance and edge distance is the perpendicular distance. So they are interrelated, like pitch distance and gauge distance are interrelated, and end distance and edge distance are interrelated. The difference is that the pitch distance and end distance are in the direction of a force, and gauge distance and and edge distance are perpendicular to the direction of force. So there are other specifications which we are going to require while designing the connection. First one is the diameter of hole. While inserting the bolt into the hole, it might be quite problematic when there is no vertical. Generally not always been a vertical, or there might be some problem. So that's why we have to keep some clearance. Okay, so we have to keep some clearance to insert the bolt. At such situation, what should be the clearance? It is refer in this uh, table. Here you can see that diameter, the table showing that serial number, nominal diameter of bolt in mm, and standard clearance. So how much should be the clearance to be provided for the different diameter of the bolt is shown in this table. Like if the diameter of a bolt is from 12 mm to 14 mm, the diameter of bolt should be greater than plus 1 mm. So if the diameter of a bolt is 16 mm, so diameter of hole will be 15 mm. In the next row, there is a diameter of bolt is from 16 to 24. The standard clearance will be 2 mm. So when there is a diameter of bolt from 16 mm to 24 mm, considered 20 mm. So the diameter of a hole will be 22 mm. So I have to mention here, when we are going to do the design, the nominal diameter of bolt is indicated by D, small d, and the diameter of hole will be indicated by the D0. Next is if the diameter of hole is greater than 24, at such situation the standard clearance is 3. Like if diameter of a bolt is 27, so diameter of hole will be 30 mm. Next point is minimum pitch, the distance between the center of the bolt in the direction of load should not be less than 2.5 times the nominal diameter of a bolt. This is important. Why that kind of a notation or the specification included in this IS 800 2007? The reason behind that is, if we reduce the pitch distance, if we reduce the pitch distance, here we can see here, if consider these bolts, two bolts which are showing the distance P, which is pitch. If we bring these bolts closer, so the stress on between this bolt hole, area between these bolt hole, the stress is tremendously increased. Area is reduces, load is constant, so stress will be increased. And such situation, if the stress increase, the chances of failure of that area is more than the other areas. So that's why the minimum pitch distance is considered and it is provided. So what is it? It is 2.5 times the nominal diameter of the bolt. Next point is that the maximum pitch. So maximum pitch, why should be the maximum pitch need to be considered? If we are increasing pitch, so the distance between two bolts is very high. In such situation, the stress transfer or the connection between the two members might be loose, and it will cause a problem. Bending or shearing problem could be happen. So that's why maximum pitch also mentioned here, where the 30 2T or 300 mm, whichever is less for the bolts in the members including the tacking bolts. So when there is a tacking bolts, what is tacking bolts? When not tacking bolts are the bolts are provided at the middle of the members, not on the only on the connection. We are providing bolts on the connection, but when we are provide bolts at the middle of the connection, or sorry, middle of the member, that bolts known as an tacking bolt. So when there is a tacking bolt, the maximum pitch distance should be 32 T or 300 mm. What is a T? T is the least thickness of the member. So you should take the least thickness of the member. Second point is 16T or 200 mm, whichever is less for the bolts in a tension member. When there is a tension members, when there is a tension member, the maximum pitch should be 16T or 200 mm. Next, 12T or 200 mm, whichever is less for the bolts in compression member, where T is the thickness of thinner plate. So 12T or 200 mm for the what? For the compression member. So here you can see that the tension, for the tension and compression member, the maximum pitch is different. So for the compression member it is less, and for the tension member it is more. Next point is the edge and end distance. So the minimum edge and end distance from the center of a hole to nearest edge of the plate should not be less than 1.7 times the whole diameter of a sheared. So here consider the whole diameter. So whole diameter I have explained previously, like that diameter of a bolt and diameter of a hole is different condition or having some clearance. So minimum edge distance or end distance will be 1.7 times the diameter of hole. Next, explanation for tacking bolt. A tacking bolt, when there is an explanation for a tacking bolt I have explained that at the middle these are the additional bolts provided other than the strength consideration. The maximum pitch of this bolt should be 32 T or 300 mm, whichever is less, where T is the thickness of the thinner plate. If the member are exposed to the weather, the pitch should not be exceed 16 times the thickness of the outside plate or 200 mm, whichever is less. So here we can see that if these members or connections are exposed to the atmosphere, at such situation we have to reduce the maximum pitch. Why it should be happen? Because when members are like a steel structure are exposed to the atmosphere, in such situation the corrosion might be happen, our strength might be reduced of the member. So that's why it happen. Next point is the maximum edge distance from the center of hole to the nearest edge should not exceed 12 T. So maximum edge and end distance should not exceed 12 T. So T is the thickness of a thinner plate or thinner member. So these are the different specification we have learned in today's lecture, and in the next lecture we are going to see this failure of a bolted joint. Why we should study this failure of bolted joint? There are 6 types of failure. Not all the failures are considered while designing the members. the few failures are considered while designing the members, because we have to check whatever we have designed, or number of bolts provided will be sustained under different conditions. So these different conditions we have to check under this failure condition. So in the next lecture we are going to see these failures. So thank you.